Okay, so in the last section of chapter 6, which is called Graph Linear Inequalities into Variables, we'll learn how to look at inequalities that have two variables, x and y. So first, I want to discuss the answer to the question of how are one variable inequalities different from inequalities in two variables. So the inequality on the left side of the screen is an inequality with only one variable here, which is x. So it's asking us to list 5 solutions to the inequality. So remember, solutions are going to be x values that make the inequality true. So one solution could be x being 0, because 0 minus 8 is less than 10. Another one could be x is 1, because 3 minus 8 is also less than 10. X is equal to 2 is also going to give us a number that's smaller than 10. So with x equals 3, and also x equals 4. So as long as it makes the inequality true, it's going to be a solution. And these are just 5 answers that I came up with. It's possible that you come up with 5 different answers. So on the right side of the screen, now we have an inequality with 2 variables because we have x and y. So we have to come up with a point that has x and y coordinate to make this inequality true. So what you can do is pick one of the variables. So I pick x to be 0. So I get 0 minus 8. And since I want the inequality to be true, I just need to pick any number that would be larger than negative 8. So I could choose 2, for example. I can also keep this 0, and as long as my inequality is still true, I'll be okay. So I just need to pick another number that's going to be greater than negative 8. So I could pick 3. Then I can pick 4, because 0 minus 8 is still less than 4. I could pick 5, because 0 minus 8 is less than 5. And then just to change things up, I'm going to change this and I'll make it 3 for the x. So then if x is 3, then I actually get 9 minus 8 less than some number here. So this is going to give me 1, and 1 is less than 2. So 3, 2 is going to be another point that is a solution. So the biggest difference is that here we just have x values. Now here we have x and y value to make the inequality true. So now we're going to take a look at what they look like when we draw the solution. So if we were to graph the solution to this inequality, I would solve this first, and I would get 3x is less than 18, which means that x is less than 6. So I would draw a open circle, and I would shade in everything to the left. So all of these numbers are solutions. So let's go back to the previous slide and take a look at the 5 solutions that were listed. And actually, I'm just going to copy. So 0, 1, 2, 3, 4. So here we had 0, 1, 2, 3, 4. All of them were solutions. Here was the 0, here's the 1, here's the 2, here's the 3, here's the 4, here's the 5. So they were all numbers that were within the shaded part of the inequality. Okay, so now over here, because we have 2 variables, when you graph this, it is now going to be graphed on the xy coordinate. So the line that where 3x minus 8 is actually equal to y is this right here. So my y-intercept is negative 8 and my slope is 3. And then since I wanted y's to be greater, if you notice, we shade everything above. And then because this is less than, it's very similar to having an open circle. So here we have an open circle. Now here, with 2 variables, if we don't want to include points that are on the line, meaning we don't want to have points where 3x minus 8 is actually equal to y, I'm going to make this dashed to say that none of the points on the line are actually solutions. Now let's go back and pick one of the points. So we had 0, 2. We had 0, 2, 0, 3, 0, 4, 0, 5. And then we did one more that was a little different, so 3, 2. So let's take a look at where they are on here. So these should be all solutions. Just like here, I'm shading in the part where the solutions lie. I'm going to shade this entire half of the coordinate plane to show that all the points in here are actually solutions. So here is my 0, 2. Nope, it's not 0, 2. Just kidding. 0, 2, 0 is the x, 2 is the y. Here's my 0, 3, here's my 0, 4, here's my 0, 5. All of them lied in the shaded region. And here's my 3, 2. It's a little bit above the line, but it is right here, shaded. So any point that I pick in the shaded region will actually be a solution. Okay, so I wanted to refresh your memory by graphing lines. This equation is in slope-intercept, so y equals mx plus b form. And you are going to graph the y-intercept first, and then my slope is negative 2/3. So I know my line's going to look like this, so I go down 2 over 3. And then here's my other line, so it's going to look like this. This equation is not in slope-intercept form, so I have to rearrange it first. So I'm going to subtract 3x. I get negative 4x. I get negative 3x plus, oh my gosh, sorry, I keep messing up. Okay, I get negative 4y equal to negative 3x plus 8. And then I do need to get y by itself, so I'm going to divide everything by negative 4. And I get y is equal to 3 over 4x minus 2. So my y-intercept is negative 2, and my slope is 3/4. So I go up 3 over 4. So it's going to look like this. Now over here, I have x is equal to 5. So this is going to be a line, a vertical line, because x is always 5 no matter what. Y equals negative 3 is going to be a horizontal line because y is always negative 3, so it's going to look like this. So y is not changing. So you definitely need to know how to graph all 4 of these types of lines in order to do well in this section. Okay, so here's our first example. It's kind of similar to what we started with. It's asking us which order pair is not a solution. So if it's not a solution, it should make this false. So it's a multiple choice question, so what we're going to do is we're just going to go through one by one and check if it works or not. So for A, I'm going to replace x with 0 and I'm going to replace y with 0. So 0 is actually less than or equal to negative 6, so this is true. For B, I'm going to replace x with 6 and y with negative 1, so I get this. Now 9 is not less than or equal to 6, so this is actually false, and since they're asking us which one is false, this is my choice. So B is your answer here. Okay, so pause the video and try these 3 problems. So you're given an inequality, and you're asked to tell whether each of the ordered pairs is a solution. So all you need to say is yes, it is a solution, or no, it's not a solution. Okay, so there's a couple of definitions that I wanted to go over. So a graph of an inequality in 2 variables is the set of all the points that represent all solutions of the inequality. So here is the set of all the solutions. The boundary line, which is this line right here, so this is your boundary line, divides a coordinate plane into 2 half planes. So here's one half plane and here's the other one. Only one half plane can contain the solutions. So this half plane contains all the points that are not solutions. So if you're given a graph and I ask you, is 5, 0 a solution? You would say no, it's not, because it's in the half plane where the non-solutions lie. all the solutions lie in here. So if I ask you whether negative 2, 2 is a solution and it lies over here, then it is yes. Okay, so here's another example where we actually have to graph the inequality. So the first thing you're going to do is you're always going to start with graphing the boundary line. So graph the boundary. So what I'm graphing is I'm graphing the line that has an equation of y is equal to 4x minus 3. Now before you start graphing, you want to take a look at this and decide for yourself whether the line has to be dashed or solid. Quick reminder, if the inequality does not have an equal sign, it's dashed line. If it does have an equal sign, we're going to fill it in and it's going to be solid. So in this case, we don't have an equal sign, so it's going to be a dashed line. So my y-intercept is negative 3. My slope is 4. My line is going to be dashed. And then I will have to either fill in this half plane or this half plane. Okay, so just take a look at this. This is saying that we want all the y's that are greater. So look at the y-axis. You want all the y's that are greater. So the y's are going to be greater over here. So on this half of the plane. So that's what we're going to shade. And I'm going to do it with a highlighter. So the y's are greater if I go above the line. So this is going to be the half plane that contains all the solutions. So these points are all the solutions. Okay, so pause the video and try this one on your own. Graph the inequality. Don't forget to check what kind of boundary line you need, dashed or solid, and think about which way you're going to shade in. Okay, so this one is a little more difficult because the equation is not in slope-intercept form. So the first thing we need to do is rearrange it. So we have x plus 2y is less than or equal to 0. Just like converting regular equations, I want the y to be by itself. So we're going to subtract x. So we get 2y is less than or equal to negative x. We're going to divide both sides by 2. And then I don't want you to get confused. So technically you do have a y-intercept. It's just 0 because we don't see anything, but we are adding a 0. So we will start here. Our slope is negative 1 over 2. So down 1 over 2. Down 1 over 2. This inequality has equal signs, so it's going to be a solid line. And the last thing I need to do is think about which way I'm going to shade in. So I want the y's to be less than or equal to, so I'm going to go below, because if you follow the y-axis, the y values are getting smaller if I go down. So this is the region that represents all the solutions. Now because the line is solid here, the boundary line, all the points that are on the line are actually also part of the solution. So pause the video and try this one on your own. Okay, so here we have to graph a horizontal line of y equals negative 3, and it is a solid line because there's an equal sign. And then I'm interested in y values that are greater than or equal to, so I'm going to highlight everything above because the y values are greater if I go above. So all the points in my yellow region are going to be solutions. And all the points on the boundary line are also going to be solutions. So that's it. So this one, and it's another example, a little different. X is less than negative 1. So x being negative 1 is a vertical line. And because we don't have an equal sign, we are going to have a dashed line. And I'm interested in x values being smaller than negative 1. So look at your x-axis. Where do the x values get smaller? Do they get smaller as I go to the right, or do they get smaller as I go to the left? They get smaller as I go to the left. So I'm going to shade on the left side of the boundary line. So all the points in my yellow region again are part of the solution. So pause the video and try these 3 examples. Okay, so this is a word problem where you have 2 summer jobs. You earn 8 hours per teaching basketball and $10 per hour teaching swimming. And a couple important things: X represents the amount of time you teach basketball, and Y represents the amount of time you teach swimming. Okay, the first thing we need to do is write an inequality. So I get $8 for the basketball, so to figure out how much money I'm earning from teaching basketball, I have to multiply 8 by the number of hours I worked teaching basketball. And then we get 10 hours per hour for swimming. And you want to earn at least $200 per week. So you want to earn at least $200. So you want to earn $200 or more. So this is the answer to the first bullet point. Write an inequality that describes your goal. Then we have to graph the inequality. So what I'm going to do here is I'm going to rearrange and get the y by itself. So 10y, so if I subtract 8x from both sides, I get 8y is equal to negative 8x plus 200. And then I'm going to divide everything by 10. So I get y is greater than or equal to negative 4 over 5x plus 20. So my y-intercept is going to be 20. And then for the slope, it's going to be negative 4 over 5. So if I go down 20, I have to go over 25. So it's actually down here. So if I go down 20, so it takes me to 0, I go over 25. Okay, so it is a solid line connecting these two. So what does these intercepts represent? This is the y-intercept. So this means that I can make $200 by just teaching swimming for 20 hours, or I can make $200 by just teaching basketball. So this line is going to represent making exactly $200. Now I want to make at least $200, so I can work more. So I want to make more than that. So I'm going to go and shade in everything above the line. So remember that since I'm okay making $200, a solution could be on the line, but I can also pick anything above the line. So this is our answer to the second bullet point. So we graph the inequality. And then it says, give 3 possible combinations of hours that will allow you to meet your goal. So I'm going to say basketball hours, which is X, and swimming, which is Y. So I can teach basketball for 25 hours and swimming for 0 hours. I can also teach basketball for 0 hours and swimming for 20 hours. So this is the first combination. This is the second combination. And then I can also pick something here, which means that I'm teaching basketball for 15 hours and then I'm teaching swimming for 20 hours. So basketball for 15 and swimming for 20. But you can pick any combination as long as it's in the shaded region or on the line, because this one is a solid line. I think this is the last one. Yep, that's it. So pause the video and complete this you try example on your own, and this is the last video for chapter 6. So now we're done.